I talked about the two parameters, specifically the new and delete, which we can use to allocate space dynamically. Okay, so what we found, I mean, are there any questions from that last class? So it was basically an extension of the dynamic allocation class that I took in the last semester. The only difference is, instead of malloc and delete, I have used new and malloc and free, I have used new and delete. So the basic focus was on the syntax of using new, and what we found is, using new, you need not have to pass explicitly the size of the data object that you are trying to allocate from the heap, and you don't have to evaluate the size explicitly. Neither you have to typecast the return type or the type of the base address to that object type. So all those are taken care of by the new operator itself. And in the delete operator, you have got two basic ways to delete. Either you can delete the 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 topmost object in that block, if I write delete p, or you can delete the entire space starting from that say base address. Okay, সন্দীপ ক্লাসে আছে, পরে কথা বলছি। Okay, so these are the basic differences between the new and delete, and we have considered all the possible cases of allocation of 2D arrays, where we know the number of rows and columns, where we know only the number of rows, only the number of columns, and all the possible cases, and the variable number of elements in a row. Those we have done, and I think we are almost we know how to use some of the features of C++, and we no longer will use C in printf scanf or malloc and free. So one more feature that we'll learn in this class is reference. So how many of you have used references in your C++ codes? How many of you are aware of the term? How many of you are aware of the terms reference?
Yes, sir.
Okay, yes, so how many of you used it in your codes?
Sir, I have used it.
So what is the use of reference? Or how many of you are forced to use it as a feature? I mean, there is no other alternative. Is there any such situation where the use of reference is compulsory to implement certain things?
So dynamic allocation.
Dynamic allocation. What's the problem? Dynamic allocation, you could have done it using pointers also.
While swapping, so swapping of the variables.
Swapping, and
what's the problem? I mean, you could have done it using pointers. My point is there any situation where you are forced to use it? I mean, there is no other alternative without using references. Is there any
constructor, copy constructor, copy constructor,
copy constructor? Yes. What? Anything else?
Passing 2D array.
2D arrays. No, 2D arrays you can say where I do not. Today is not that important. Okay, so I think some of you have already used it, either knowingly or unknowingly, or maybe. So in this class we'll see one case where you will be forced to use references. Maybe we'll use it extensively later on, but we can at least point out the situation where we need this. So you really cannot skip the the knowledge of reference when you are dealing with the object-oriented language. And those who use Java, so I think Java supports reference, right?
Yes, sir.
Do Java support pointers also?
No, sir.
So see, so there's a kind of change. In C, it supports only pointers. In C++, it supports both pointers and references, because pointers we have already checked it. Reference will be learning it now. But in Java, it supports only references but no pointers. So are you getting what I'm hinting at? So whatever you can do using pointers probably can be done using references itself. Is that fine? I mean, that may be a very general statement, but this seems to be true. So almost anything that you can do using pointers, you can do it using references. I mean, the purposes or the objectives that you had. But there are few things that can only be achieved using references. And probably that is the reason why all the modern languages, I mean, at least from Java onwards, they didn't uh, provide the facility of declaring pointers or dealing with pointers. In Python, do you have any pointers concept?
No, sir.
Hello?
No, sir. No,
So
sir.
pointers are, I mean, it is not like obsolete, but it's a better way to do things without writing those nasty, asterisks and then ampersand and all this. So things are, so, so at least the readability is more, but you still have the same, uh, say, flexibility to do as you have pointers while dealing with pointers. Okay, so that is the objective of learning this reference as a new feature, and which will be used not only in C++. So once we know references, the first thing that probably we do is we no longer use pointers in most of the cases. We'll stick to references more often, and our codes will look probably smarter and compact and more readable, right? So the idea is to gradually switch from C++ features to more object-oriented features. Sorry, from C features to object-oriented features. So we have done up to that. So these portions we have done in the previous semester itself, and this portion I have done in the last class. And here we focus now. So we generally know that, so I think you all are aware of pseudonyms, right? Pseudonyms are a very well-known word in English dictionary. And if you look into the, if you just Google it, you will find that pseudonyms include stage names, user names, ring names, pen names, okay, nicknames, whatever you say, code names used by hackers, and superhero identities used by the actors. Okay, so gamer identifications and all this. So pseudonyms are something that we are all aware of, and we often use it in our real life also. So a pseudonym is an alias, is a fictitious name that a person or group assumes for a particular purpose. Now, whether it is for good purpose or bad purpose, that's a different thing. But we often do that in our real life also, which differs from their original or true name, which in this terminology we can call it as orthonym. Okay, so these are the words that I just found it from Google. So when we talk about reference, so reference is something that is related to pseudonym. So we just try to assign a pseudonym to an existing data variable or to an existing named identity. Maybe it's a variable, it's a constant, or it's an array or whatever. Okay. So if I have already created something, I would like to assign a new name to it. So in a real world, the objective, why do we need, why do we intend to create pseudonyms, additional names? What is the general objective?
Nobody can recognize us.
Yeah,
To
sometimes.
hide our identity.
Yeah, so you have got different objectives at different times. So it can be to hide the individual's real entity, real identity. Generally, the pen names writers do that. Actors, it's not that hiding, but they would like to be recalled or named by that, so that it has got some professional, it adds some professional value to them. And sometimes it is to showcase a particular persona of a person. of a particular human being. So that is the intention. And sometimes without unknowingly we get pseudonyms, right? So like the faculties or the teachers, they usually get pseudonyms from the students, and sometimes they carry the same pseudonym that some long back some batch has given, and he's generally known with that. So one that I know that maybe with the initials SN is a common pseudonym assigned to me, but there may be many other names which I do not know at all, right? In the social media, I mean, the students used to call me in that name. Maybe based on my characteristics, whether good or bad, I'm given names, and different batches give different names. So even though you do not like it, or unlikingly, you have to accept. So the thing is, it has only use in a certain context, right? Just a minute. Let me plug in the power source. Okay, so the pseudonyms are part-time names that can be used only in certain context. That is important. So definitely, when I am in my office, so some I people call me my own names. My friends call me different names. The students call me as SN, like that. But when I'm in my home, probably I I'm called with some different name. So based on the context, we use the name. So that is the reason why the same entity, the same person is. আমি ক্লাসে আছি, সব পরে করো, ক্লাসে আছি। Okay, so in programming language, a pseudonym is created by using the feature called reference. Okay, so I think you know what the purpose is, and let's see in the programming domain what is the purpose of creating a pseudonym. So if say for example, say this is a value, say I write here int x equals to 10. That means what? I have created a constant integer which is allocated this space and this particular 4 bytes meant for storing the constant integer is named as x, or is identified as x. So do you know how these names associated with a variable is tracked, is how the system or your compiler keeps track of it? Runtime environment keeps track of it. How we people, we the faculties keep track of your names and all this?
Using a table.
Yes, we usually have the registers and all this. So attendance register. So in the attendance register, we have the names and the roll numbers, and then the attendance details and all this. But the roll number and the name, we maintain it like this. And in the case in the system also, the compiler also does the same. So it maintains a table which is called a symbol table, because these names are nothing but symbols associated with that particular set of locations, right? For this x, these 4 bytes is associated with a symbol x or a name x, whatever you say. It's a variable name or a constant name, whatever. Now the overall system maintains a symbol table which says that which location you are referring to, 2005. Okay, so it means starting from this, what is the type of that particular entity? It is int. And what is the name to which it is identified? It is x, right? And once it is int, that means that the remaining 4 bytes are actually recording or storing the content of that particular entity. So the name of the entity here is x, and a symbol table consists of and generally there is a symbol table which keeps track of all such entities with their names listed here, and their base addresses and their data types. Okay, so that is how the system maintains all the distinct symbols associated with a particular variable declaration or a constant declaration. Is that fine?
Yes, sir.
And this is better known as symbol table. It's a standard terminology. So a reference is a feature that allows a programmer to provide an additional name to an existing data item, variable or constant. You can use nicknames, or you can assign nicknames to existing variables or even existing constants that you have declared already, right? So here, if x is say these are the 4 bytes which is assigned the binary of 2, okay, and this is identified by x in the symbol table. Because you have done that, you have done this. So if I would like to assign a new name to this same location, to the same value, I would like to call it with some different names. What should I do? Is that part clear? Can you see this?
Yes, sir.
So now you see the same thing is there, but I just added one name to it. Like whenever a new faculty comes, he knows his name is this, some XYZ. But whenever he starts taking the classes, the student scans all his features, how he walks, how he talks, and how he reacts, and all this. And immediately within a week, he gets a new name. And it might happen that different batches give different names based on their observations and their whatever. So likewise, we in our codes also, we can create multiple names associated with a particular entity. Maybe it's a constant or variable. And this is again, as I mentioned, it is creating alias to that existing entity. And how I do this? Can you see this? The syntactic change. So here, how I specify this is an ampersand. So this is another symbol through which I achieve that aliasing. And this symbol, what is the other use of the symbol?
Address.
To get the address.
Get the address. So that was a different thing. So sometimes I would have used something like this. So this means what? I'm trying to get the address of this X. So when I'm using it here, that was a purpose. But the same symbol I have now overloaded just to use it to declare or to create new aliases. Okay, so this is not related to anything with the address. When you are writing it in the declaration of some addition of some new symbols or names, this means you are trying to create a reference of some existing entity. And whose reference you are creating? You are trying to create, in this case, the reference of the pre-existing entity X, where X is a simple variable. Is that fine? What is this? Now, doesn't matter. I can assign few more names to that also. So now I say that the same entity is, I would like to associate the symbol Z also with it. So these 4 locations, doesn't matter what it stores, because it is constant, you cannot change it. Sorry, it's a variable, you can change it. So this can be identified as X, Y, or Z, all are the same. So that's why when I write cout X, Y, or Z, what do you expect the output?
222.
Because they are all the same. So in the department, if somebody calls me SN, I will respond. If somebody calls me maybe Subroto, I'll respond. Or if somebody calls me with some other names, maybe my friends has given me long back, so then also I'll respond. So the same thing, because it's all related to the same person, right? So, but then the basic question is, you say that, okay, so how to keep track of all these X, Y, and Z, all these 3 names? What kind of change I need to have? I need to be there. There need to be in the system to keep track.
Should always also put these names into the table.
The symbol table. So in symbol table, earlier you probably accommodated, or you had say 1X. Now you say that X, then comma Y, then comma Z, and you can have any number of them. So probably to accommodate this, the C++ symbol table was a bit bit more generalized in terms of C, so that it can accommodate. So nothing more than that, right? So when you write a compiler, or when Strauss wrote the compiler, he just did it like that. But that was a nice feature which was used not only in C++ but in other languages also, object-oriented languages generally. So now if I write y++, then what do you think? If I write y++, so will it affect only y? Because it will affect the entity, and the entity is the only entity identify different names. So the thing is, if I write y++, if I again display x, y, z, what do you expect? It will be displaying
4, 4, 4.
now why it is 4? It is 3. It was 2, then it was incremented by 1, it is 3. So what will be the output? It will be 3, 3, 3.
3, 3, 3.
That means here you say that I would like to increment the entity, no matter by calling whatever name it has got, either of the 3 names. It has got 3 names, x, y, z. But the effect will be the same. It will be just incremented by ones. And now if you would like to display the contents of that particular entity by calling its different names, it will all display the same thing, that is 3. Is that fine?
Yes, sir.
So now one can create multiple reference. Yes.
Hello,
Any question? So
Sir,
one
if
can.
you
Yes.
hello, sir.
Yes.
Sir, if you make increment by x plus plus, then its value changes to 4, 4, 4
Yes.
before the previous slide.
If I now after doing this,
Yes, sir.
if I write here
After
x plus
making
plus,
y plus plus,
so then it will be
see out x, y, z, and l. Then
yes,
the
it will
value
be
should
this is true. You can increment it at any number of times, but each time you do that, that gets affected, this gets modified, and if you try to display with different names, the same value will be displayed, because after all you are trying to display the contents of that same entity, maybe identified by different names.
okay.
Is that clear? Hello? Is
Yes,
that
sir.
okay? So now what we can say, one can create multiple references of an existing variable, as we did 3, 4. You may go on creating 10 references, but the thing is, if you don't use it, or if you really require it, there's no point of creating so many references, because after all it will burden your memory, right? And it will unnecessarily complicate the thing. I mean, this is not required. So we generally do not give aliases to unknown or the persons whom we meet occasionally. We don't do that, because I know that the context of meeting that person is just once. So why do I try to associate different names for that? So one can create reference of a particular type. Okay, because when I am trying to create reference, so y is going to be a reference of x, some existing entity x, but I have to write here, I have to specify the type of this particular entity. The original entity's type need to be mentioned here, right? So that's why I say that one can create reference of a particular type. So when you create a reference, you have to associate it with a type. In fact, it is the type of the entity whose name you are going to create. A reference must be initialized when declared. That is very important. Now, can you assume, like, your batch has not seen the department yet, and probably you have not taken a course from some faculty, say for example, say somebody, say Shondeep Kormokar. So he has not taken your class at all. So do you want to have from your batch associated alias for him?
No, sir.
So the thing is, you don't probably write something like this. Does it make sense?
No, sir.
that means, what is the intention? The intention is PP. Because class আছে পরে phone করছি. So the intention is to create a new name, to assign a new name to some existing entity, because I'm using this symbol. So, but the thing is whom I am not specifying. So it's completely vague. So in the symbol table, it says that what should I do with this PP? Because you say that I am creating a name for somebody who will join later. That's all vague. So that's why a reference must be initialized. Otherwise, it does not make sense. That's the sole purpose of creating a reference. It is not satisfied. Okay. Now, once a reference name is assigned to a person or to a variable, can it be assigned to others?
No, sir.
So there is one Sanjeev Sadhu and one there is Sujoy Shah. So there are two faculties, probably some of the classes you have. So if you people give both of them the same alias SS, so there will again be ambiguity, right? Because when you refer to them, it will be ambiguous. So in the same programming paradigm also, once you have utilized a particular symbol or a name for assigning it to a particular say entity, you cannot reuse it and you cannot change it also. So reusing probably could have been possible, but you cannot change it. So you cannot say that, okay, in the second year we used to have classes from Sujoy Shah, so we used to call it SS, and in the third year when Sanjeev Sadhu takes the class, you say that no, from now onwards SS will be Sanjeev Sadhu. So that is again ambiguous. That's why it is not done. So once you assign a name, put a name, you cannot take it off and then assign it to somebody else. Is that fine?
Yes, sir.
So these all make sense because it's intuitive and logical also. So creating reference does not create additional space in the RAM. That is for sure. Because if the entity does not exist, you cannot create alias. So this is writing this is just a mechanism to create aliases only. It is not giving the first name to that. It is giving the second, third, fourth names. So no additional spaces are allocated. And if that is not the case, so do you think that dynamic allocation can be done for references? For a reference variable, can we go for dynamic allocation?
No, sir.
Does not make sense, right? Because creating a reference is only assigning a name to an existing one and no additional space is created. So you cannot say that let us dynamically allocate space for a reference variable. You can dynamically allocate space for a variable or for a entity whose values will vary and all this. But references cannot be dynamically allocated. And null references are also not possible. Null references means they must be initialized. You cannot defer it, or you cannot assign it to a null. References must be connected to a legitimate piece of storage. Creating an array of references is not possible. So can you see this? INT. What is this? What is probably the intention of me of writing this? So this is a reference symbol. So I say that what does this say? A is going to be an array of 10 integers, one dimensional array of 10 integers, or I mean this A is going to be a name associated with an array of 10 integers. So this is not possible. You cannot create array of references. That is not possible. You cannot even write this also. And you cannot write this also, because this 3 is a constant, right? It's a literal.
Yes, sir.
And you cannot just make it appear like a
Variable.
like a normal integer value.
Yes.
Okay, it can be made possible only if you write then it is possible, because this 3 is a literal, so it expects that to be the same. So the thing is, this array of references is not possible, and then you cannot just write assign a literal directly to that, because that is not associated with the space, any space. Up to this, is it fine?
Yes, sir.
So what is the difference between reference and pointers? You cannot assign, you cannot have null references, but you can always have null pointers, right? And then a reference must be initialized when created, but pointers may be initialized at any time. So generally when we write int asterisk q, so this means q is a pointer variable. Now you may assign it the address, you may just leave it as blank, leave it uninitialized, either this, or you may assign what value? Null value to it, right?
Null.
So all these are possible while you are dealing with pointers. But when you are dealing with references, try to create a reference of the same x, you have to write like this. You cannot leave it as blank, this portion. You cannot assign null. So this is essential. So the thing is, the reference must be initialized when it is created. Pointers can be initialized at any point of time. And we cannot have null references like this, like the pointers. And once a reference is initialized to an object, it cannot be changed to refer to another object. Pointers can point to another object at any point of time. So like if you have got x and y, two integers, okay, at some point of time you write this one, but at some other point of time it can be assigned the address of y also. Okay, so the pointer variable q can sometimes point to x, can sometimes point to y, but this r, once it is done, you cannot again write that r will be an alias to y also. So this is wrong completely. Is that part fine?
Yes. Yes, sir.
Yes, sir.
So I think so the best way to denote it schematically is something like this. So we have got, say, this is the memory and this is int a. So this is say a. Okay. So this is the original name of the entity a. When I'm here, when I execute this one, I am trying to assign another pointer variable p and assigning the address of a, so that p can point to this entity a. Okay, so if this is 2019, so this is 2019. That's why it can point. Now I create a reference of a in terms of q. Then how do I refer? So how do I denote it? Earlier its name was a. Now it has got another name, or you can say its name is now q. That's all. So this particular entity, earlier it was named as a, now it was named as. So there is no other, as you can see, like as p, there was no additional space that was consumed in the memory for keeping track of this, or for renaming this. The only thing you can assume or you can expect is some entries are there made in the symbol table associated with this storage unit starting from 2019. Is that okay?
Yes, sir. So it means the queue will only store in the code segment. There will be no definite allocation for the in the data segment.
Which one?
So for the queue,
for the queue.
yes, I mean the alias which we're using. If we use alias, I mean int ampersand q equals to a, then we do not need any we do not need any memory allocation for the queue. I mean it will not stored in the data segment. It will only stored in the code segment.
No, it may not be in the data segment. It can be in heap segment also. I have not mentioned that these are global, so that you assume it to be in the data segment, right?
Yes, sir.
So it may be in this segment, but the point is there will be no additional allocation either in the stack segment or in the data segment or in some other segments. The only thing is you can assume that it will have an additional entry in the symbol table. So symbol table is a part of your runtime environment. It's a part of the runtime scenario. Because when the code actually starts running, the symbol table need to be tracked and maintained, and all these need to be done. So in the symbol table, it will have some entry that, okay, this particular entity will be now associated with two names, A and Q. No matter which one you use to call it or refer to it, it will work. But there is no additional space, as you can see here, is allocated in this in some segments, whatever it is. It may be heap segment, sorry, it may be data segment, it can be code segment, sorry, the data segment, we don't know. Is that okay?
Yes, sir.
So I think conceptually we can associate it with like this. So A or Q to the same thing, and then P is a definitely a different entity. It's a pointer variable. So it's a variable means it will occupy some space, and as we have initialized it to address of A, so it will be pointing to that. So that is different. And this Q is just another tag added to that existing location A. Right. So there are indeed there are differences between pointers and references, and the differences are right from the concept itself. But why we are trying to compare it, because compare both of these two, because they are having sometimes similar impact when you pass it and while calling functions and all. So we'll see it shortly. Okay, so can you see the screen?
Yes, sir.
So here, as you can see, I have just declared int x equals to 5, and then I am trying to write what is the intention of line number 35, 36, 37?
35 is alias of x. I mean R1x is an alias of x.
And then 32, 36, it's alias of
R1x.
R1x. That means what? Is it any different?
Alias of X.
So it's same. So you say that my name is Shubroto Nondi. So you say that, okay, your batch gave me an alias of SN, and maybe some other batch or some other person says that we are giving a alias or new name to SN, means the same thing. So he's indeed giving the alias to the same entity. So either when you create an alias, you see, so R1x is alias of X and R2x is alias of R1x, meaning the same, because once you are writing R1x, you could have written here X, whatever, and R3x also is the same. So the thing is, in this process, if this is X, so it will be known with X, R1x, R2x, R3x, right? All are associated with this storing value 5. So now once you have created multiple aliases, nothing is original and something is secondary name. It's not like that. So all the names are having the same kind of priority or whatever, are in the same level, you can say. Is that fine?
Yes, sir.
They are just names, multiple names, that's all. Now, it is not like a real world that, okay, SN is just an alias name and that is the original name, it's not. So all are in the same level. So now if I write cout, you see cout, here I am displaying X, here I am displaying R1X, here I am displaying R2X, R3X. So all will be displaying what? The value 5.
5.
Then I write Rx, R2X plus plus. And then again I am displaying these values. What do you expect? So again,
All 6.
all will be incremented by 1 and it will be displaying all 6. Because now this 5 becomes 6.
Sorry to interrupt, but previously you asked us to interrupt you at 45 minutes mark.
Yes. Thank you. So I've got another 5-7 minutes left. So what is this? int a1 4 this. So what is this? This is an integer. So this is an integer array. Storing value 2, 4, 6 and 8, right? So this is an array, and so this base address is identified by a1 in the symbol table, right? This one.
It's an A1 array of 4 integers.
Yes, so this is a A1, this is an array of 4 elements. This is what it means.
Yes, sir.
Now I write, so what is the implication of this statement in 45, line 45?
So A3 is the name given to the element present in the second position of A1.
So the thing is, the only in the second position, that means only this particular element of the array, I am trying to associate a name A3, right? Are you getting the point? So I have got a whole bunch of students, but I would like to call a specific student as to be the CR. So I give an alias name CR. So when I in the batch I call, okay, CR, you come. So he will come. So I probably do not care about renaming the other students, but I care about renaming that particular student whom I will refer often with a specific name that you would like to have, right? So it's something like that. So you may not create the alias of the entire array, but you can create alias of a specific element of the array as you wish. What about this one? (46). Now this is again a pointer variable. What is this?
It contains the address of base address of A1.
So that means what? So P is a pointer variable. This is P, right? This is a pointer variable P. Now it contains A1 means what? We know that it means the base address of the entire array is copied there. So that means P is capable of pointing to this one. The base address, that's fine. Now what about this one?
So reference to a pointer P.
That means what? So now you are
Q
creating
is an alias to P.
giving another new name to this same pointer variable P, right?
Yes, sir.
So now if I write here these statements A1, 2, then A3, then P2, and then Q2, what does it mean? A1, 2 means A1, 2 is simple. It's actually 6. We all know. What about A3? What is A3?
So it is also 6.
A3. A3 is a new name given to that, so that is 6, right? Given to this third element. What about P2? P2 is no, so P is a pointer. P of 2 means this, so it will also refer to 6, right? And what about Q2?
So it will also be 6.
It's also
because
also 6.
Q is just a new name given to the same pointer P, right? It will also be the 6. Is that fine?
Yes, sir.
Yes, sir.
Okay, I think almost it is 50, so I should end it up. So just one last point is, this is what? This is a two-dimensional integer array of 2 rows and 3 columns each. And then this B2, what is the intention of B2? What does it mean? So B2 is a reference to an integer entity. What is that? It is the 0th row and the first column element of that 2D array. So in this 2D array of this one, 0th row and 0, 1. So this one. So this particular element. So this particular element is better identified as B2, right? I would like to give a new name to that. Associate a name. It's a new name. I would like to associate that particular element of that 2D array with a new name, with a specific name, say B2. Is that fine?
Yes, sir.
Okay, so that's all. So in the next class, I'll be talking about the passing by references and returning references. So these will be the things, and then pointers and constants. So that will, so another 10 minutes will be required. So I'll take the class in the next in tomorrow, and there I'll have a brief discussion on the generation of random numbers. I've given some of the reading stuff. I would suggest you to go through that or find the wiki page. So are there any questions? So we have not yet encountered the situation where we are forced to will be forced to use references. So we'll see in the next class. So we have just given the introduction of reference, how to create, what it means,